the matter that's all around you can be broken down into components. So for example, you could take a table and rip it in half. And then one of those pieces could be ripped in half. And you could continue dividing the pieces in half almost indefinitely. But eventually you would reach the point where they cannot be split up any further. And the particles that are left over, when you can't break them down any further, those are known as atoms. And atoms are small, like really, really small. Whatever you're imagining in your head, they're smaller than that. So for example, you could imagine a diamond. And diamonds are made from one type of atom, carbon. And now imagine a very small cubic diamond that measures 1 centimeter by 1 centimeter by 1 centimeter. That's a fairly small piece of material. And if you actually manage to break that down into individual pieces and you get down to the level of atoms, that would have an absolutely enormous number of atoms. It's so many atoms, in fact, that I don't actually know the word to describe it. But I will write out the number of atoms, roughly, that would be in a piece of diamond that large. So, as you can see, atoms must be absolutely tiny. And now that we've got that kind of incomprehensible size scale in your head, you need to learn that atoms aren't the smallest thing around. Each atom is actually composed of individual pieces known as subatomic particles, so smaller than atoms. And there are a bunch of different subatomic particles, but there are 3 types that are relevant for this course. And they are protons, neutrons, and electrons. So these subatomic particles are absolutely tiny. Protons and neutrons are similar in size and weight, and electrons are much, much lighter. So you can see that protons and neutrons have a mass that's almost identical, and the electron mass is about 2,000 times smaller. These subatomic particles also have electrical properties, so they can have electrical charges that are positive, negative, or neutral. And atoms themselves that are made up from protons, neutrons, and electrons are always electrically neutral, which means that the total charge in an atom is 0. So the atoms have to have an equal number of positively charged protons and negatively charged electrons so that the charges cancel out. And they can have varying number of neutrons because they don't affect the charge. Another point in the structure of atoms is the idea that they're roughly spherical. So they're arranged that the protons and neutrons are crammed together at the center of the atom, and the electrons are arranged around that center. And the compact, highly dense area that contains the protons and neutrons is known as the nucleus. So the nucleus of the atom contains the vast majority of the mass, since the protons and neutrons are far heavier than the electrons. And in addition to being the heaviest part of the atom, the nucleus is also kind of the smallest. Its volume is about 10,000 times smaller than that of the entire atom. So that means the atoms can kind of be considered mostly empty space. So if you put that in a bit of perspective, if you scale up the size of an atom so that the nucleus is about the size of the City Hall building in St. John, that would make the edge of the atom, so the farthest place you could find an electron, be somewhere in Ontario.